Welcome, everybody. Welcome to the dark economy of stolen cloud accounts in phishing attacks. I'm trying to take a quick moment to thank our sponsors, Tenable. Tenable are leaders that must reduce the risk of breaches while balancing staff and budgets. Tenable Cloud Security is a comprehensive cloud-native application platform, aka CNAP, that simplifies the identification and remediation of cyber threats across multi-cloud and hybrid environments. Unlike siloed tools that offer fragmented visibility and limited context, Tenable discovers and maps every cloud asset, identity, and risk, identifying toxic combinations and attack paths that pose the greatest threat to your business. Detailed remediation instructions, developer code, and automations improve productivity while reducing costs and risk. Thank you, Tenable, for being a gold sponsor. And welcome to the talk, The Dark Economy of Stolen Cloud Accounts and Phishing Attacks, by Bruce and Stefano Chierici. Take it away.
Hi everyone. So thanks for joining. Today we're going to talk about of stolen cloud accounts for phishing attacks. So this is something that we investigate with the customer. So today we are not going to go through all the kind of details about the customer. The point of this talk is kind of putting some lights on what we discover during the investigation and also bring some light on the dark economy of SCS accounts. So today we're mainly going to talk about AWS SCS, and then we are going through some details on the investigation that we did. So let's just start on a couple of words about AWS SCS for who's not familiar with that. So it's pretty simple, and this is one of the the most used email feature in AWS. How it works is very easy. So the sender is using AWS SCS API in order to send emails. The emails will be delivered to the recipient's receivers, and then, of course, the email will be dropped into the inbox of the receiver, which, of course, might not exist, might exist, or the recipient might mark it as spam, and so the feedback will be then sent back to the sender. So far so good, no many news, right? So what is really interesting instead is what you need to do in order to enable SCS in an AWS account. When you start and you want to enable SCS, let's suppose that you want to start using that, you need to enable it. But when you enable it, you start into a kind of what they call sandbox mode, right? In sandbox mode, you just can send email to verified email or pre-verified emails, and you have just a very limited amount of email that you can send per day. In order to move away from this sandbox mode, you need to open a ticket to AWS. Of course, you need to provide a lot of information, like how you want to use the service, for which reason, the goal, and all the bunch of different information that you need to provide them. Of course, with proper time and let them validate the request, you will finally be able to reach the production mode, where is kind of an unlimited way to use SCS, and you can send a lot more emails, like 50,000 emails per day, and you can send emails to anyone. Of course, in this case, so you can potentially use the service properly without no restriction. The other important thing is that SCS is actually DKIM approved, and that means that, of course, it's going to use DKIM in order to guarantee authenticity and integrity for the emails that are sent or received. Of course, this means also that if attackers are able to compromise a cloud account where SCS is enabled and is in production mode, that means that they can leverage this security feature on their advantage, so that they can send emails with high reputation and, of course, not marked as spam, as we know, and so it's kind of look legitimate, but of course they are not. So that's a couple of words on how SES works, but let's now dip a bit deeper into dark economy of that. Of course, this all starts with the fact that, as we said, it's kind of not difficult, but it takes some time, right, to have a SES ready to use, an account that is production mode that is ready to use. And of course, you also need to provide a lot of information and a lot of things which attacker, of course, they might not want to give away, or they might don't want to do that. So, and that's where it's open a kind of black market of accounts that are compromised and can be used for phishing attacks, for instance. So that's something that we saw in this case. In this case, we went through different forums, different Telegram chat or different Discord chat as well, and we saw a kind of very different type of accounts that are on sale, not just related to AWS, but even for other cloud provider, but for the purpose of this talk and for the purpose of our investigation, we went through the AWS and we saw kind of very different things. The price is usually between $600 and $800, but it really depends on how many emails they can, or the rate limit that they have on daily. Usually 50,000 might be more if the account owner requests more. And the other point is in how many regions SES is actually enabled. So if they have more regions, of course, the price will rise up. And of course, if the attacker were able also to compromise the cloud console, the console, AWS console, or just via CLI, for instance. So these all factors that can rise the price and so on. The other point, which is very important in our case, is the reputation, right? If the sender reputation is very high, of course, this could be leveraged to deliver emails, and of course this will increase the price for the selling price, of course. In this case, and what Bruce is going to go through, usually we have two different threat actors. So one, there are part of the threat actors that are interested in compromise as many accounts as possible, where SES is enabled, so they can sell them to other threat actors that will then use to properly do the phishing campaign and move on with other part of the attack. So I'll let Bruce introduce what we saw and the investigation that we did.
All right, thank you, Stefano. So now I'm going to show the phases of this offensive operation that we investigated with the collaboration of the customer. And as Stefano said, it involved two different threat actors, one which gained access to the AWS account of the victim, while the second threat actor that bought the access to this AWS account in order to launch a phishing campaign. The attack started with the exploitation of a Laravel application running on a Kubernetes container. And we actually didn't have visibility on this Laravel, on this Kubernetes pod, but we can say that we can infer that the Laravel application was used for testing purposes. And we don't have any confirmation about the precise CV that was exploited, but we can, according to some later investigation, we can say that it could be likely the CV 2021 and 3129. Also because we know that there are several scripts in the wild that are exploited to automatically exploit this vulnerability. Right after exploiting the vulnerability, the attackers started to go for the credentials in the pod. So specifically, they stole AWS credentials that were stored in the environment variables as well as the AWS credentials. And this allowed them to pivot into the AWS account of the victim. Of course, once they pivoted into the AWS account, they started to call some AWS APIs, which contain some references to JavaGhost team, which is an Indonesian team, which was already reported in an article from Datadog, as well as in some Reddit posts describing offensive activity on targeting SES. Doing some factor research, we found several scripts on GitHub belonging to some members of this JavaGhost team. And they were basically just info stealer scripts aimed to steal AWS credentials and then abuse the SES account of the victim. So now we have the first threat actor, which can be Java Cause itself, or maybe some other Indonesian team using the tools of the Java Cause. I say Indonesian because in the recon phase that we see later, most of the API addresses were Indonesian. So once in the AWS account, what these attackers started to do was, of course, targeting SES. And to do that, they were mainly interested in knowing if the AWS keys had access, had proper permission to call those APIs. And second, if the SES account of the victim had production access. And that was actually the case. So on the right, you can see the most commonly used APIs in order to gather those kind of information. For example, the first one is the most common one, the get account, because it returns a lot of useful information for attackers. For example, it returns if the production access was enabled or not. It returns the first field, which is the status of the sender reputation. So in this case, it is healthy, which means that likely the emails will get directly in the inbox of the recipients, as well as the quota limit, which in this case is the default one for production access. And the last field is if the account is enabled or not to send those emails. After gathering all of this information, this attacker had everything sufficient to start sending emails. And to do that, they started to call the send email API. One important thing to say here is that the APIs to send emails of SES are not logged on CloudTrail, which means that by default, they are not logged. And SES provides two different ways to log those kind of APIs, which are via CloudWatch or SNS. Since this AWS account had CloudWatch enabled, CloudWatch logging enabled, we were able, thanks to the logs provided by the customer, to analyze the logs sent for these first test emails. Because this actor started to send some test emails in order to check if they were correctly sent. And so, thanks to these logs, we could collect all the email addresses of the recipients, which likely belong to the attacker itself, so they could verify that the email was correctly sent. After first group of test emails that were sent from some Indonesian IP addresses, we saw some other test emails that were sent from some French IP addresses. And we were able, therefore, to collect also the email addresses belonging to what seems to be another threat actor that entered the game in this stage. So in this stage, it seems that this selling of the account was was in progress, so that also the second threat actor was testing the sending email stuff, and in order to launch a phishing campaign, which is actually what happened like a few minutes later. In fact, less than an hour after the second group of test emails, real phishing emails started flooding. And thanks to the CloudWatch logs provided by the customer, we were able to understand what the goal of this second threat actor was. Specifically, those emails were targeting Navigo users. And Navigo card is a transportation card used in Paris and provided by a French company called Île-de-France Mobilité. And we saw also that this company, Île-de-France Mobilité, was victim of a data breach in the last October, so a few months before we saw this attack. And from the articles describing this data breach, we read that this breach resulted in the email leak, in the data leak of 4,000 of email addresses belonging to Navigo users. So it's very likely that the second threat actor got access in some way to this data leak. We have no evidence, but we could infer that. So now we have a second threat actor which got access to this AWS account and started a real phishing campaign. What you see here is an example of a CloudWatch log for one of those phishing emails. And it contains a lot of user information for investigation, for example, the IP addresses of the sender, as well as the email addresses for both the sender and the receiver. It contains also, of course, the subject and the AWS user that sent the email. Unfortunately, it doesn't contain the body of the email, but we can infer what the content was based on the other factors. For example, on the right, you can see all the sender email addresses that were used by the attackers. You see that the alias can be arbitrarily chosen by the attackers, as well as the user, but not the domain the sender, because of course the domain is one of the verified identities in SES, because SES provides two kinds of identities, or email addresses or domains that can be used to send those emails. So in this case, they were tied to the verified domain of the AWS account. From here, we can see that the attacker was impersonating the Navigo support. In fact, we can read stuff like service client, Navigo client, and the subject in this case is French, and it means like your membership card has been suspended. So we can guess that the email was something like, in order to renew it, click here, and of course, it would contain a malicious link aimed to steal some credit card details of the recipients. In that time, we in fact saw that Ile-de-France Mobilité released some announcements of an active phishing campaign that was targeting Navigo users, and also we saw that their Twitter account was full of users reporting phishing emails that they received in the last months. So if CloudTrail cannot be used to log send email APIs, we wondered how can we detect and respond in an automatic way to this kind of attack. So we came up with an approach that can be easily implemented for attack scenarios like this, and which starts from the configuring SES to send SNS notifications for every email that has been sent. And for an SNS notification triggers a Lambda function which can do like any kind of custom checks on the emails. So for example, we can do custom checks on the IP addresses in order to implement, for example, a whitelist and say, okay, if the IP address doesn't belong to this whitelist, mark it as suspicious. Or we can apply whitelist on the sender, on the receiver, and so on. And we can make the Lambda act accordingly. So for example, if we think that the email can be suspicious, we can remove the permission to the user that sent those emails, or we can even just call an API to turn off the sending capability of the SES account. Also, other than making checks on single emails, we can even decide to use CloudWatch alerts. For example, CloudWatch provides some useful metrics for SES. For example, the rejected, bounced, and compliance emails. So for example, we can say after X emails rejected in a specific time frame, trigger the Lambda and act accordingly. So this approach can be easily implemented to detect and respond to a scenario like this, but not only for SES, because there are other services in AWS that have like impactful APIs which can be used as an attack that are not logged on CloudTrail. So this approach can be like scalable and used for other attacks as well. And now for impacts and takeaways, I leave to Stefano the stage again.
Yep, thanks. So I'm just going to spend a couple of minutes on impacts and takeaways. So the main impacts, of course, are on the account owners, as we saw. So first of all, company reputation damage in general. Of course, if you send emails or send phishing emails with SES that is used for other purposes, of course, this can lead to company reputation damage. But even more important, there might be some also decreasing the SES and the reputation, which of course is a key, as we saw, to be marked as spam or not. So if SES account has been stolen and it start to be marked as phishing and the reputation goes down, of course also all the other like legitimate email will be marked as spam as well. And of course this might be like very bad for the account owner, which is supposed to use the image as it should. Of course, if attackers will reach the daily limit in the account, of course, this means also potential denial of service for the account owner, because they can't send any other emails because they reach already the daily limit, and that's it. So this will be also a potential denial of service. And of course, the end user will get the annoying phishing emails, which of course will lead to credential theft and whatever else might be. Just to close with some takeaways, of course, hopefully we brought some lights on this dark economy on NCS, which of course is real and is still going on, right? So pay attention to this. We also wanted to contribute back to open source project, as we used to do. We actually create a module in Stratus as well, and we create some Falco rules. Thanks also to our colleague for doing that and helping us on doing that. Apart from that, of course, least privilege is not an option, as we know, so it all starts with misconfiguration, and we all know, so misconfiguration is a big deal. We all know that. And also, when we talk about detection, of course, CloudTrail is not the only source of truth, right? So we need to be creative, and we show our approach and how we did in order to create some detection and detection and also respond in order to in this specific case. Of course, vulnerability management, and of course be sure to have visibility into cloud on using proper tool like CSPM, CM in order to validate what you have in your cloud account, what is going on, state object, which we know is a big deal. So thanks. Here is the link on our research and our link, our X, if you want to get in touch, and of course we are happy to answer other questions. Thanks.
Thank you, Bruce. Thank you, Stefano. We have time for a couple quick questions. If anybody has some, just raise your hand. If anything, I've got a question that kind of struck me. You had mentioned there's a couple threat actors, one that you attributed to Indonesia and one that you attributed to a French threat actor. Were there any other indicators besides IP address that led you to those conclusions, or were you going based off of IP address from the threat actors that you concluded?
Mainly on the IP addresses and the scenario. So, for example, mainly on the IP addresses and on the scenarios of this attack. So, for example, the target was some French users. So, yeah, this makes sense.
Yeah. Anybody else? Oh, we got one here.
Hello. So with SES, I have DOS our system before because we have to send 200K verification email. And with the detect and respond solution that you have, which is to remove the IAM permission. So wondering what is the quick response like recovery that you can do for the solutions that you have, because that we have to send a lot of email to get, for example, Cognito require SES to send verification email. So in regards to your solution, like how do we recover quickly from, because you remove this permission. So how do you recover that quickly from allowing business to send email?
Well, since we can use Lambda functions, you can like really customize it. I mean, if you can afford to remove permissions, you can go for it. Otherwise, you can, for example, alert you by sending an email or send a Slack message, and make like if you cannot afford to like do some proper response, you can just alert a team of people and let them like do the investigation. I mean, it really depends on your use case. If in this case, for example, the customer was okay with removing permission to specific users, but I can of course understand that it's not possible in every case. So it really depends on your use case.
Cool. Thank you guys. Appreciate it.
Thank you.
Thank you.